Right, so, you can see okay? Yep. Previously, we saw how to solve simultaneous equations. And we also saw that if we have two lines, that we can be sure, pretty much all of the time, that they'll meet to give us one solution. There is one situation where they don't meet to give one solution. What's that? When they're parallel. What we're going to look at today is what does it look like to solve a quadratic meeting a linear. Now, the way I drew it, how many solutions are there? Two. But of course, there could be one possible solution situation where you maybe have the line meeting the quadratic here at one point. And of course, it's also possible no points. That you have a quadratic and you have a linear and they just don't meet. So we could have 0, 1 or 2 solutions for these problems. Yeah? Right, so before we look at an example, just draw those diagrams, please. Can I scroll down? Okay. Yeah? Scroll down? Yeah. So, let's have a look at an example. Suppose I have something like y equals minus 2x plus 2 and y equals minus x squared minus 3x plus 4. Now, when we studied simultaneous equations, degree 2 equations, how many methods did we have? What were the methods called? Do you remember? Substitution, elimination, and sketching. Yeah. However, there's only really one method we can use for these problems. Substitution. We can't use elimination because we can't cancel. Well, I guess we could cancel the y using elimination in this question. Substitution is the usual thing to do here. Because this equation equals y, and because this equation equals y, we can say that minus 2x plus 2 equals to this. Yeah. Now, I'll take everything to the left. X squared plus x minus 2 equals 0. Did I do that right? X squared, x minus 2. Yeah. Okay, let's see what solutions we have. Well, it has to be a plus and a minus, and it has to be 2 and 1, doesn't it?
Yeah.
Yeah. So, what do I get for x? X could be minus 2 or 1. And so, how would I get the y?
Put x into the...
Into here.
Yeah.
Yeah. So that would be 4 plus 2, 6, and 0. Now, to finish, I just want a very quick sketch. Very quick. So my first point is minus 2, 6. So that's here. And my second point is 0, 1, which is here. Now, Kei-Hong, two problems. One, you're speaking Chinese, and two, you're speaking when I'm speaking. Okay? So, can you guys look up, please? Jeffrey? Yeah. Did I do that right? Sorry, no, I did that. Yeah. Yeah. I was distracted. 1, 0. Here. Yes? Is that right? Yep, okay. Now, the linear is, what is the slope of the linear?
Minus
So it should be going up or down? And it is, see? And the quadratic, is it a U shape or is it a hill shape, an N shape? N shape. So I don't do it like this. Instead, I need to do it the other way, don't I? Well, okay, whatever. You get the idea. There, okay. Quadratic and linear. Sorry, the reason I drew it so badly is because I know that it's supposed to cross the y-axis as well at 4. So that's what I was trying to do too. So it's a very rough sketch. What we have here is 2 points of intersection here. Also, interestingly, we actually found one of the roots as well, because this is on the axis by coincidence. So, okay, so write this one down, please. Okay.
So after you do this simultaneously,
Yeah.
so you still have to factorize.
No.
You factorize.
Oh, I did, to get the axis.
No, that's not much.
Yeah. Yeah. Okay, you got that? And don't forget the quadratic. You didn't draw the quadratic.
Right.
You did not draw the quadratic.
Yeah, I will do now.
Thank you. Right. Can I scroll down? Yeah. All right. So what I want you to try for me, to just practice one, I want you to try this one. Write this one down. Y equals minus x plus 11. Okay. And the quadratic is y equals minus 2x squared plus 7x plus 3. After you get the answer, I want a quick sketch as well. Solve and sketch this, please. Okay, did you write that down?
I talked to a picture or something.
After the answer. Let's have a look. Okay, did you all finish that? What was interesting about the answer?
X is 1, Y is 1.
Just one answer. Yeah, just one answer. So when you solve it, you get minus x plus 11 equals minus 2x squared plus 7x plus 3. So that is, what's that? 2x squared
Minus 8 plus 8.
Plus
Plus
8.
8.
equals 0.
Yeah.
Yeah, which is x squared minus 4x plus 4 equals 0 if you divide by 2. And you get only one answer, isn't it? X is 2,
Yeah.
which makes y equal to 9.
Yeah.
So when you sketch this, what's happening? At the point 2, 9, they both meet only once. So what's happening is your line, which is going down, and your quadratic, which is downwards as well, it must be something like this. Does anyone know the name of this situation when the line and the quadratic meet once?
One linear, one quadratic.
No. Anyone? I think you do. Tangent.
Oh.
Tangent line. Yeah?
Yes, tangent.
Oh, tangent. Ah, now I get you. Yes. Right. Yeah. Okay. Can I give you one more? But it's a hard one now. I'll scroll down. Can I scroll down? Yeah. So I don't. I don't want to pick numbers too big. This one looks reasonable. Okay, try this one now. It's a little bit different. 5x plus 2y equals 0. And minus 5x squared plus 8xy plus 4y squared equals 0. Now, how is this different? Yeah, what will you need to do first? Make y the subject. In which equation? No. The first one. And then what do you do? Sub it in. It's actually not easy to make y the subject in the second equation. Now, it's not impossible, but it's actually quite difficult. So make y the subject in the first equation and sub it into the second equation. Give it a try. Yes, actually, that works too. That's another way to do it. Just something went wrong, Jason?
Yeah.
What went wrong?
Equal 0.
That equals 0.
Yeah, so
X 0, Y 0.
0, 0.
Yeah.
Another can
Fine, that's the answer.
Yeah.
There's nothing wrong with that, is there?
another cannot get the answer. As X will be eliminated.
What do you think? Okay,
Do we have to sketch it?
No, sorry, don't sketch this one. Okay, so if we look at the answer here, I'm sorry, I was being, guys, are you looking up? I was being a bit cruel here. This one is a very peculiar one. So in the first one, you can make y equal to minus 5 over 2x. Yeah? And then you sub that into the second one. So you get minus 5x squared plus 8xy plus 4y squared equals 0. Okay. So now you have minus 5x squared minus 20x squared. And then that's...
25.
X squared.
So what quadratic do you get here? Yeah.
No answer.
No.
No solution.
Yeah. Hang on, I think Ming has it. Put t equal to...
X over y.
Yeah.
Yeah.
And?
And this can turn to just like the past question. It's put t
Yeah.
equal x
Yeah.
over y.
X over y.
Yes.
Maybe.
And you add a second equations divide y squared.
Oh, maybe. Maybe not.
Oh,
So look.
I start from the second equation, and you will find there will still one way to not know answer.
Yeah. So, in this question here, this was a very hard question. So if we were to say what would we say the answer is? There's no answer, there's one answer.
0, 0.
One answer.
You would say there's one answer.
One answer.
And that answer is
0,
0, 0. You're saying no answers, not even 0, 0.
If we do that, it's no answer.
Okay, now I just want to see. So, you're saying one answer, you're saying no answers. Even 0, 0. Yeah? Anything else?
No answer.
Yeah, you're going off now to the city centre, yeah? Okay. Now tell me, if x is 0 and y is 0, is the first equation true?
Yes.
Marwan, look up. If x is 0 and y is 0, is the first equation true? Yeah. If x is 0 and y is 0, is the second equation true? Is 0, 0 a solution for both equations?
Yes.
Yeah.
Of course.
So, yes. So we have at least one solution. So we can't say no solutions. Okay? Now, what about if I was to use something like, let me think, 0, 0. Suppose I put in 2 and minus 5. Let's check it out. 5 times 2? 10. Minus 2 times 5? 10. So is it a solution here? Yeah, and trust me, if you put it into the second one, it will be a solution as well. Oh, so we have two solutions. Okay. Well, what about if I try 4 and minus 10? 5 times 4? Minus 2 times 10? So in fact, what's happening here is not that there's no solutions or one solution. There's actually infinite solutions.
Every pair is a solution.
Yeah, I can think of many pairs that will work. And the way I'm generating these numbers in my head is using this formula. Yeah. So what's happening here? Well, this is kind of like what we saw in the simultaneous equations. If I have this, I have no solutions. But what if the two lines are on top of each other? I have infinite solutions. They meet infinitely. Okay? That's what must be happening here. The reason that there's infinite solutions is it must be the two of them are lined up. That they overlap infinitely. Okay?
So the second one is not a quadratic.
Yes, isn't
Is
it?
that right?
The second one is a quadratic. No, it's not a quadratic. The second one, if you were to I'll tell you what's happening here. The reason I asked you not to draw the graph is because you don't know how to draw the graph. But what's happening is, if you were to draw the line, it would look like this. Fair enough? If I was to draw this. if I was to draw this, it would look like, hang on. Yeah, it's two lines. I think there's one line that goes like this, and then one line that goes like this. It looks like an X. So the reason for the infinite solutions is that you're getting all the solutions where the two graphs meet, they overlap. I think, there might be solutions along this line as well where the two overlap. Okay. So like I said, that is the hardest question I could think of for this lesson. Okay. I doubt they would do this in the exam, but I just wanted to do a super hard one with you. Okay. So your homework, which you can start now, I'll give you 4 questions. I'll say 1D, 1E, 2A, and 2F. No, actually, didn't I give you one of those earlier? No, we won't say, no, we'll say 1A and B instead. One A, 1B, 2A, 2F.
Teacher, I have a question.
Yeah. Huh? I used this. I imagined an X and a Y, so this is true.
Okay.
Yeah. Okay, did you write those down? 1A, 1B, 2A, 2F. Yeah? Okay. I'm closing this.